Okay, hello everyone and welcome to Control System Analysis and Design. In this video I'm going to give you a basic outline of Bode plots, just the real basic rules of how to kind of draw them and set them up. So when you're working with Bode plots, if you've never really seen them before, you have two plots. You have the magnitude plot and the phase plot. Both of them are with respect to frequency, and it's on a logarithmic scale. So you have point 0.1 and then 1 and then 10, so it goes up by powers of 10 here. Now, with this plot right here, what I have, I'll just go ahead and change this to 0.1. Whenever you're drawing these Bode plots for control systems, you always line them up so they're on the same scale so that you can actually compare the Bode plots, which will be important later on when you're doing like phase margins and gain margins. So the Bode plots are fairly simple as far as that goes. But if you're given a transfer function, like say s plus 0.1, I'm changing this to 0.1 because you'll see in a little bit. You have to figure out, well, how do I draw the magnitude and phase Bode plot for this specific transfer function? So what you do is basically, I'm going to change it a little bit more here. Just give me a second. It'll be helpful in a minute. With Bode plots, when you're looking at a transfer function, and say we've got s plus a over s plus b s plus c. And this is your transfer function. So you've got the 0 right here, and the poles down here. So these are the two poles. For every one of these poles, the b, the c, the a, each one of them is a pole value. What they will equate to when you're doing the magnitude plot is for a pole, it will angle the plot down 20 degrees per decade. And if you're not familiar with decades, a decade is from here to here. So each kind of cycle from like 0.1 to 1 onward. It shows better now. Okay, and then if you have a 0, the part in the upper in the numerator, then it angles it back up from 20. But it goes on forever. If you draw a Bode plot, the magnitude Bode plot, and you're going along, and then you hit a pole and it angles down, then it's going to continue going down in forever until like a 0 shows up and angles it back up. Now, in order to show this, with like this plot, I'm actually going to change this back to 1. And putting the 1 right here, what you do is if you have the initial value of the Bode plot, you just go along at 0 until you hit the point 1. Like I said, the frequency is the same as the value of the pole. This is just 1, not 0.1. Make that very clear. But then once you get here, you go to negative 20 dB per dec. So in order to draw that, you can just put a dot right here and kind of sketch out a line. You go down 20 degrees, as shown right here. And then you would just go on until infinity. Let me get my ruler. At negative 20 dB per dec, if that was the case. However, if I add in, say, s plus 2, well, 2 is right here. Up here, but this is a 0. So right here at 2, I was going down at negative 20 dB per dec, 20 decibels, but now that I hit this point right here for the 0, it's going to level back out and go straight again. So that's how that works. It would have gone on into infinity, but since there's a 0 at 2 now, at 2, it changes angles plus 20 and comes back up to level. So a pole makes it angle down to 20, but then you hit the 0, and it angles it back up to 20 and goes on. Okay, so now for the frequency plots. When you're looking at a frequency plot, which is the one down here at the bottom, and I'll explain it in a minute, a pole will cause a negative 45 dB per dec slant, so it angles down at negative 45 degrees. And then the 0 causes the opposite again at positive 45. Now the trick to the frequency is that this negative 45, a pole has the effect for 2 decades. So over 2 splits right here. So 1, 2, just like that, 2 decades. Which means that it has a total effect of plus or minus 90 degrees. Now this is important because if you have a pole or a 0 at the origin, which would be like the origin of a root locus plot, or if you have, say, let me draw this, 1 over s of s plus a, well then this 0 is at the origin, so the frequency plot automatically starts at 90. just to encompass this, because it doesn't really have a value to start with. And you'll see that more in examples later, but I'm just making a note of it right now. But in order to show how this negative 45 plus 45, but actually over 2 decks works, if you're looking at this and we're still using this transfer function without the s plus 1, and you go to do the phase plot, well, how you do it is, okay, well, we have a pole at 1 because it was 1 over s plus 1, and it's going to go down at 45 degrees per deck, right over here. But since it's over 2 decades, it's both in the negative direction and in the positive direction. So the point of the pole is at the center of this slant, basically. So what you do is you take the decade values above and below the value of your 0, and basically draw the line from there. So you're going along, I'd say 45 degrees, because that's what your system gave you, and that's what the gain of the transfer function was. And then you would hit 0.01 because that's the first decade below your actual pole. So you go down at negative 45, but then that pole's effect basically fizzles out and disappears, and you go along straight. And then, of course, if you had like a 0 show up in here or something like that, say you had something like s plus 1 over s plus 1, which obviously just equals 1, but I want to make this point here. Well, you've got a 0 at 1, but you also have a pole at 1. So the 0, what it wants to do is create a slant basically like this. So it's going to positive dB per deck, or 45 dB per deck, just like this. Now, but when you're adding up these Bode plots, because that's basically what you do, you add up the effects of the zeros and the poles. If you add these up, they end up being 0, so then your Bode plot would just be a straight line. So you can see how this effect works. Well, when you have a point at 1, you go to a decade below and a decade above for every pole in 0. And if it was like 2, well, then you go at 0.2 and 20 and create the angles there. And then as they show up, you add them up to create the final Bode plot. And if you watch one of my final videos, you'll see one of my other videos, you'll see how this works when I work a couple of examples. So that's the basic outline of Bode plots. Each one has an effect of a certain number of degrees, depending on magnitude or phase. And then you basically just add those up to find out what the sum effect is for your final Bode plot.